Well, good afternoon. Welcome to MOS Live. You are joining us just in time for our coolest science stories, where we'll be talking about some exciting new developments in the world of science. And we'll have a chance to answer some questions from you about the three stories that we're going to share today. Now, if you're joining us on Zoom, you can go ahead and start entering your questions anytime you'd like by clicking the Q&A button on your screen. If you'd like captions, you can access those by clicking the closed caption button at the bottom of your screen and selecting Show Subtitles. Now, if you're joining us on Facebook or YouTube, unfortunately, we cannot see your questions at this time, but we are thrilled that you're tuning in. All right, so let's get started. My name is Megan, and my pronouns are she and her, and I'm going to be starting us off with a story about quantum physics education, and a little later, I'll be talking about a new way to identify birds, but I'm also joined by another fantastic educator from the Museum of Science, so I'm gonna ask her to come on now and introduce herself.
Hi, thanks, Megan. My name is Meg. My pronouns are she and her, and I'll be sharing a story about how kids can help some citizen science projects learning about childhood development.
Awesome, super excited for that. All right, well, let's get started. I'm gonna just get my screen up here. So I'm gonna start us off with that story about quantum physics education. Now, as September approaches very soon, one thing that's on a lot of people's minds is the start of the new school year. And even though school will be a lot different for a lot of students, the curriculum should be pretty much the same. There'll be math, history, biology, and what about quantum physics? Now, quantum physics is the study of the tiniest building blocks in our universe, like atoms and particles, and it's usually not something you learn a whole lot about until you get to college. But that might be changing. This month, the National Science Foundation announced the National Q12 Education Partnership. This new program is joining forces with the US government and other institutions to introduce quantum science and technology into kindergarten through high school education. The goal is to prepare students to become part of the future quantum workforce. But what's a quantum workforce, and why do we need one? Well, let's find out. Now, quantum physics is often portrayed as a lot of complex equations on chalkboards, but the theories of quantum physics are more than just a lot of math. All that math tells us that quantum particles, like the electrons inside an atom, or photons, which are particles of light, well, they can do some pretty amazing and unexpected things. Like they can be in two places or states at the same time, something called superposition. Now, let's say these two quantum particles can be in two states that will represent as green and purple. Now, if a quantum particle was in a superposition of these two states, well, that means it's green and purple at the same time, not a blend of the two. It's all the way green and all the way purple, all at once. Now, things on a human scale don't really behave this way. If they did, this cat could be standing up and laying down at the same exact time. But there's more. Quantum particles can also have a powerful connection between them called entanglement that allows them to affect each other. Now, let's assume that these two particles are entangled, and one is purple and one is green. And if we change the green one, the other one automatically and instantaneously changes to purple. And this will happen even if you separate these two particles across the whole entire universe. And there's a lot more cool stuff to learn about quantum physics, but aside from it just being fascinating, there's another really important reason to learn about it. Quantum physics could be a huge part of the future of our technology. Now, scientists are right now harnessing the cool properties of the quantum world, like superposition and entanglement, to create new quantum technologies. Things like quantum computers. Now, by harnessing the properties of atoms and particles, quantum computers might one day be able to solve certain types of problems that are way too hard for even the most powerful computers that exist today. They'd be good at things like climate modeling and discovering new medicines. Scientists are also building new quantum communication systems that could keep our information safe from hackers. By encoding information into photons of light and entangling them together, scientists can create a quantum key, like a secret code that's nearly impossible to break, allowing us to send information securely. Imagine never needing to worry about hackers stealing your credit card information if you try to buy something online. In the future, we could use satellites and other forms of quantum communication to send information from quantum computers around the world, creating a new quantum internet. But in order to make things like a quantum computer or the quantum internet a reality, we need more scientists and engineers who can create, build, and maintain this new technology. We need a quantum workforce. By learning the basics of this science early on, students who are interested in pursuing careers in quantum science and technology will be ready to dive into the details when the time comes. And even if you don't work in the field of quantum science, well, we all need to understand what this new technology is and how it might affect our lives. And that's the goal of the National Q12 Education Partnership. Over the next decade, this partnership will establish lessons and resources for students of all ages that will make quantum science and technology education accessible to everyone, so that people, no matter who you are, can understand and appreciate this exciting and fascinating field of science. So keep your eye out for more quantum science as it expands into our educational institutions. And if you're interested in learning more about what students might be learning through this new program, you can check out the key concepts for future quantum information science learners at qis-learners.research.illinois.edu. And now I will pass it over to Meg, who has a super cool story about childhood development.
Thanks, Megan. What a great development in the curriculum for all of our little listeners. Sorry. All right. So we're going to stay in the world of with little kids for a little bit. But first, I just want to remind you that if you are joining us on Zoom and you have any questions, you can type them into the Q&A box at the bottom of your screen, and we'll answer as many questions as we can at the end. Now, have you ever wondered what babies are really thinking, or how a toddler learns new skills? Kids learn so much so fast, they're really amazing. And when they're born, a baby's brain actually already has all of its brain cells or neurons, all 86 billion of them. But over the first few crucial years of their lives, these budding brains are actually forming 1 million neural connections per second, building up the framework that underpins their understanding of the world. Scientists who study how kids learn look at all sorts of aspects of their development as they progress through different milestones, like the first time they smile back at you, recognize their own name, or the first time they wave bye-bye. Now, these researchers have all kinds of tricks up their sleeve for figuring out what's going on in a kid's mind. But traditionally, these kinds of tricks involve meeting up in person in a lab. But more and more, and especially just recently, due to the novel coronavirus, labs are looking for online ways to connect with study participants. And at the same time, lots of families are finding themselves at home and spending more time together than ever before. So these unprecedented circumstances led researchers at MIT's Early Childhood Cognition Lab to make the most of this unique opportunity and push to help scientists meet parents and children where they are online. Their new citizen science website is called Children Helping Science, and it debuted just recently, and it collects together dozens and dozens of studies from all over the world that are all looking for kids to sign up and help them understand childhood development. Over the past several years, researchers have proven that study methods using online participation via internet browsers and webcams can reliably record things like where on the screen a child is looking, how long she's looking at it, and her responses to prompts. And these are really important tools because even if a baby is too young to tell you what she's thinking, what she pays attention to is a really big clue. So the fact that online tools can track this information means that remote studies have serious science potential. To take just one example, did you know that when you were a baby, you already understood physics? One MIT study called Your Baby, the Physicist looks at how babies between 4 and 12 months of age understand the world around them. In multiple brief sessions, babies are shown pairs of videos through Look It, which is a platform for recording and analyzing the baby's response. For instance, you might be shown a video of a ball rolling down a ramp over here on the left. And on the right, they'd be shown the same video, but this time the ball rolls up the ramp instead. And then researchers try to measure which video holds the baby's attention more. It turns out that babies are fascinated by objects that seem to defy gravity or disobey other laws of physics. They know that something is just not right about what they're seeing. Even just a few months old, babies really have absorbed a lot of information already about the world around them. Your Baby, the Physicist is just one of the many, many studies collected on the new Children Helping Science Citizen Science site. And these different studies are grouped by age, ranging from newborns to teenagers, and there are even some that are looking for parents to participate. By expanding studies like this online, the researchers are able to reach participants that might not be able to come into a physical lab to take part, like families that live really far away, or families that don't have time during the day to make the trip, or at the moment, families that are quarantining. Researchers are really excited about this too, because they need lots and lots of participants of all different kinds to get clear results. And recruiting enough families is always a huge challenge for these studies. Online recruitment through Children Helping Science will help them gather more data than ever before, and that allows them to see more detailed and more reliable results. Here's an example of one little physicist completing many study sessions, which allows the team to take multiple snapshots of her behavior, even seeing how that behavior might change over time. And in fact, one of the goals of Children Helping Science is to make it so easy to get involved that researchers can pursue longitudinal studies, which means they follow children over a long period of time to track their development. And if families participate in multiple studies they find on the website, we might be able to start understanding the timing of when different skills develop and how that timing is related. One lead researcher described the platform as the Hubble telescope of child development because of the never before seen depth of focus it can provide just by widening the lens or the net to gather lots and lots of participating families. So if you've got little ones that might be interested in participating, check out childrenhelpingscience.com, and who knows, maybe we'll see some more coolest science stories in the future. And with that, I'm going to hand it back over to Megan for one more story.
Great, thanks, Meg. It's amazing how much babies already know and how much we're learning about it. And it's going to be really exciting to see what else they learn from those studies. So cool. All right, now we are going to switch from humans to my very favorite organism, birds. Now, how easy is it to tell the difference between these two bird species, a house wren and a blue jay? Well, it's not all that hard, right? The house wren is small and it's brownish, and the blue jay is a little bigger and it's blue. Well, what if I asked you to find this particular blue jay in this group of blue jays? Well, now this is not so easy. It can be really hard to tell birds of the same species apart. But this is actually something that scientists who study birds have to do a lot. They need to be able to tell individual birds apart. Now, typically to identify individual birds, the birds are fitted with little numbered metal bands and sometimes colored bands on their legs so that scientists can tell the birds apart by looking at them. But relying on humans to identify the birds this way can be challenging and time-consuming, especially because scientists usually have to identify a lot of birds. And this is because answering scientific questions about birds, like how long they live or how they behave, well, it requires a lot of data. But now scientists may be able to get some help from artificial intelligence. Now, artificial intelligence is the technology that allows computers to do things that typically only living things like people can do, like making decisions or using language or having the ability to see and perceive the world. And this might bring to mind things like advanced robotics or self-driving cars and things like facial recognition software. But it's also useful for applications in biological research and conservation. And now, an international team of scientists has found a way to use the same type of artificial intelligence that's used to recognize faces to recognize individual birds. Now, it's a type of artificial intelligence called a neural network. And the neural networks I'm referring to are computer programs, but they're actually based on how our brains take in and process information. And they're particularly good at learning to recognize images of things. For example, the two birds in this photo are the same species, and they look really similar to us. But a neural network can pick up on subtle differences in the birds that we can't easily see. And with this new study, scientists created a neural network that can identify individual birds by looking at images like this of their backs. And here's how they did it. They chose two species of birds to study in the wild, a bird called a great tit and another one called a sociable weaver. And they also chose one species to study in a laboratory, a zebrafinch. Now, in order to get the neural network to recognize individuals of these species, they had to train the program by showing it lots and lots of different pictures of these birds. Now, to get all these pictures of the wild birds, they briefly captured the birds and they fitted them with a small microchip called a pit tag. And then they attached an antenna that detects the pit tag to a bird feeder. So kind of like how a toll booth detects an easy pass tag in a car, when the bird gets close to the antenna, it detects the bird's pit tag, and then it sends information to a computer that tells a camera, also attached to the bird feeder, to take pictures. So every time the bird lands on the feeder, the camera snaps a bunch of pictures. So they did this over and over and over again until they had lots and lots of pictures of each of the tagged birds. And they also used automated cameras to take lots of pictures of the zebra finches that they were studying in a laboratory. Then the scientists used all the pictures that they took of these birds and they used it to train the neural network. So by showing the neural network lots and lots of these pictures, it basically learns by trial and error to recognize each of these individual birds. And after a while, it got pretty good at this. Actually, when they tested out the neural network, it was about 90% accurate for all three of the bird species, which is really good because remember, it's not trying to tell the difference between these three species of birds. It's trying to tell the difference between individuals of the same species, which is a lot harder. So this is a really exciting start, but these scientists are still trying to improve this computer program, and there are a whole bunch of challenges that they need to overcome. And one of these challenges is just the changing of the seasons. Because some birds, like this blackpoll warbler, well, they change their appearance when they molt their feathers during the year. So this would make it really hard for a computer to be able to identify them at different times of year. Now, artificial intelligence programs like this, they won't replace important types of identification like banding birds. But still, scientists are pretty excited about the idea of automated bird identification because it could be an exciting tool for certain types of researchers who are trying to learn more about the lives of birds. And the more we know about birds, the more we can do to protect them in the future. All right, well, that concludes our stories. And now we'll have a chance to take some questions. So I'm going to invite Meg to come back on and join me. And I have a question for you, Meg. Are there any things that they've already learned from baby physics that you might be able to share with us, or is this like an ongoing research?
Yeah, it is an ongoing study. So they don't have a paper published with results that I could explain to you right now. But just generally speaking, the kinds of effects that I described earlier, where if you show babies two different situations, one which actually looks like the real world and one that looks kind of like the real world, but the laws of physics aren't behaving properly, there has been a noted effect that babies do pay more attention to the one that looks a little bit off, which was partly the motivation for this study, to try to quantify that effect. And I'm really looking forward to hearing what they've learned from it, from being able to show these videos to lots and lots of different babies and different ages, and then see what kinds of little differences they might be able to tease out of it, and what tell us something about how perception of the world around us changes a little bit over time, or how babies learn, how babies taking in the world around them, how that changes over the course of this window from like 4 to 12 months. Yeah, so stay posted on the actual results coming soon, I hope.
So cool.
I have another question for you, actually. I was going to go back to the first story, and I'm wondering, are there any quantum effects, all these strange things that you described in the quantum world, are there any that we might see in our everyday lives?
Oh, that's a good question. And the funny thing is that these quantum effects are happening all the time. But we don't really see them because they're happening on such a teeny tiny scale. But because these are the kind of effects that happen, on the scale of atoms and particles, which make up everything, really, these quantum particles are kind of the foundation of everything. So really, at our most fundamental level, we are all quantum and all being kind of governed by these strange effects, which is really interesting. But there are some ways, and some really interesting ways. There are probably some more obvious ones that aren't coming to my brain right now, but just one interesting one, because I love birds so much. Recently, people discovered that entanglement may actually play a role in how birds navigate, allowing them to actually see the Earth's magnetic field in a way. So it's not really it doesn't just apply to physics. There's a whole field of quantum biology where people kind of study how these quantum effects really play out on the scale that we're used to. That's a really great question. So Meg, I have another question for you. Are there any other studies on children helping science that you can maybe mention that might be interesting to people? Any that you've noticed on the site, or any that might be interesting to our viewers?
Sure. Yeah, so there are actually literally dozens and dozens of different studies, all divided up by age group. So depending on how old you are or how old your little one is, you might be able to find something that a researcher from somewhere in the world is looking to understand about that particular age group. A couple that I've noticed that I like, there's one that's for infants, like I think just a few weeks old, where the researchers are trying to understand when babies start to mimic their parents' facial expressions. So I've seen a couple of photos from that study, and they're very fun looking because they involve a parent sort of sticking their tongue out, and you see when the baby starts to stick their tongue out back, that kind of thing. There are also a lot that are specifically related to the effects of COVID-19, the psychological effects on children and also on parents, which I think is going to be a very interesting development coming from all this, is sort of understanding what some of the effects on all of us have been of remote learning, for example, and all of the different things that we've been taking in stride for the last several months. So I'm really curious about those as well.
Yeah, that's really interesting, because it's not just that these studies are so cute and they're interesting, but they're also really important for a lot of reasons too. And bringing COVID-19 into it and figuring out how that's affecting really young children is really important. Yeah.
Yeah, definitely. Yeah, you make a really good point, because I tend to see these studies. A lot of them just seem very fun to participate in, but the results of them are really impactful too. So the fact that anyone can sign up to help out with that, I think is just really really meaningful in a way. And I admit I have signed up my infant son and myself for some of them as well, and they are quite fun. um,
Yeah.
so we still have a few minutes. So I want to ask you a question here from Prisha, age 8. She wants to know, how many birds are there?
Yes, there are a lot of birds. There are about 10,000 species of birds in the world. And here in our area of Massachusetts, I think there's about maybe 400 species of birds, maybe about like 1,000, 1,200 in the Northeast, something like that. So a lot of birds. Compared to other types of animals, there aren't that many. If you think of something like insects, right, there are lots and lots and lots of species of insects. I think there's like 300,000 species of beetles alone or something like that. So there's not as many birds as there are insects, but there's a lot of different types of birds. And that's one of the reasons that it makes it difficult for scientists to study them sometimes, because there are so many different species. And yeah, lots to keep track of. That's a really great question. All
Well, I
right,
have
well,
a follow-up. Oh, sorry. Also from Prisha, I should have grouped these. But are birds endangered? Some of those birds you just mentioned?
yeah, there are a lot of species of birds that are endangered. Some, right in our area, or if you're in the Boston area, wherever you are, there are some species of birds that are endangered. And there's a number of reasons for that. Things like climate change and cities expanding, even just things like people keeping their cats outdoors, and birds flying into windows. There's a whole lot of things that threaten birds, but there are also a whole lot of things that people can do to help protect birds. And you can also, like, you can become a citizen scientist on Children Helping Science. There's a lot of ways to become a citizen scientist and help birds too. Yeah, great questions. Well, I think we are just about out of time. So thank you all so much for your wonderful questions. I don't know if we quite got to all of them, but thank you so much for submitting them. They were wonderful questions. And now I am going to give Meg a chance to say goodbye before we close out.
Thanks, everybody. Goodbye.
Thanks, Meg. All right, so we have so much more going on over at MOS at Home. So check us out on the website or follow us on social media. And if you enjoyed this program, please consider supporting the museum by visiting us at engage.mos.org/welcome. And your support will help us continue to bring this online programming to you virtually and free of cost. All right, well, that is it for us today. Thank you again so much for joining us and for asking your wonderful questions, and we will see you next time.